Hello everyone. I'm going to talk about some periodic terms including atomic size, ionization energy, and metallic property. First, I'm going to ask you to think about atomic size of elements in the periodic table. Based on this sample periodic table, you will find we can compare elements on each group or each period. If we are going to compare elements in one group, like this trend is going to be applied. Size increases down a column. If we are going to compare size of elements in one group, as you see here, so size increases if we move from top to down. So I'm going to write it here. If we have elements in one group, if you are going to compare elements in the one group, if we move down a group, size increases. So we predict we have largest atom on the bottom of the periodic table because on each group, elements on the bottom of each group, they are largest element in that specific group. How about if we are going to compare elements are placed in one period? Look at these elements on period number 2. So as you see here, the trend is like this one. Size decreases across the period. So I'm going to write it here. If we have elements in the one period, if we move from left to right, size decreases. So size decreases if we move from left to right the periodic table. So we may have this summary. Elements on the right side of the periodic table, they are smaller in size. As you see here, they are always smaller than elements on the left side of the periodic table. So I'm going to summarize these trends. First, I'm going to remind you elements on one group size increases if we go down a group because we are going to have more shell numbers. So the reason for this one is number of shell increases. Group number 1 elements, for example, hydrogen period number 1, 1 shell. Lithium shell number 2. Sodium, it has 3 shells. Potassium, 4 shells, because we know that period number, it gives you the number of shells. So potassium has 4 shells, sodium 3, lithium 2, hydrogen 1. More shells means electrons can be placed in farther than nucleus. So we are going to have larger atoms. How about if we have electrons in one period? When we have electrons in one period, it means we have the same shell. So all of the elements in the one period, they have the same shell number. For example, period number 2 means 2 shells. What factor affects on the size? As you see here, number of protons and electrons are going to change. Whenever we have more protons, it means we are able to attract electrons more. More protons, they have more attraction. So electrons can be closer to the atom. When electrons can be closer to the nucleus of atom, so we call that we have a smaller size. So more protons or more atomic numbers, it means we have a smaller in size when we are going to study elements in one specific period. So let me back to this slide. Elements in this period, they have all 2 shells, and it depends on their atomic number. So for example, lithium, beryllium, boron, carbon, I'm going to write their atomic numbers here. More protons here, it means they attract electrons more, and we are going to have electron closer to the nucleus, so smaller in size. So as you see here, when we move from left to right, size decreases. Ne has a smaller size than, for example, lithium. elements on the right side are smaller than elements on the left side. So if I'm gonna ask you to keep this information in your mind whenever you are going to solve your problems in exams or any homework assignments, I may say regarding the size, so largest atom are placed on the bottom of the periodic table and smallest atom are placed on the right side of the periodic table. So this is a summary of these two trends, a smallest atom and largest atom. So you may remember only these two. Please pay attention. Largest atom on the bottom and smallest atom on the right side. So if we are going to compare group and period. So let me work on a couple examples. Let me work on a couple examples based on this one. Question says, choose the larger atom in each pair. Carbon and oxygen. Carbon, oxygen. They are placed in one period. They are placed in one period. So we know that if we move from left to right across the period, size decreases. The reason because more atomic number, it means more attraction. Electrons are closer to the nucleus and we have a smaller size. So oxygen is smaller than carbon. So question says larger one. So we should pick carbon atom. So we reviewed elements in one period. How about lithium and potassium? So let me focus on these two elements, lithium and potassium. They are placed in one group. So when we move down the group, size increases because shell numbers increases. Shell number increases. Potassium has 4 shells, lithium has 2. More shell means we have larger in size. Right now, I'm gonna focus on carbon and aluminum. Carbon, so let me erase these two. I'm gonna ask you to think about this. Carbon and aluminum. As you see here, these two elements, they are placed in two different groups and two different periods. Aluminum group 3, carbon group 4. They are not in the same group. Carbon belongs to period number 2, aluminum belongs to period number 3. Two different periods. What happens if we have like this? So the only thing we can say here, we need to move from one element to reach another element. So if I move down and I move left, I can reach aluminum. So if I have carbon atoms and I'm gonna compare with aluminum, I just need to pick one of those like carbon. So to reach aluminum, I need to move down and back to the left to find the aluminum. If you move down a group like this, in a group you go down, so as you see here, size increases. So size increases. So I move down the group, I say size increases. How about if we move from right to left? If we have right to left in the period. So right to left. So please look here. Left to right, size decreases. If we move right to the left, size increases. Size increases. So I'm gonna write size increases. Both make same result. Size increases. So aluminum is going to have larger size than carbon atom because we have the same behavior. So you may do another pathway to follow and get the aluminum. So you may say I'm gonna move from right to left and then go down. So right to left, so size increases, and if you go down, So again, size increases as well. So you may say, I'm gonna start with aluminum. I'm gonna start with aluminum. So let's see how it works. If you are going to start with aluminum. So if you start from aluminum, go to the right and go to the top. So let's see how it works. If you move from left to right in the period, move from left to right. So size decreases. So we predict size decreases. How about if we move from down to top in the group? How about if we move like this one, from bottom to top? In the group, we have like this. Down the group, size increases. So if we have opposite behavior, opposite pathway, we should have opposite behavior as well. From down to top, size decreases. So I can also say size decreases. So I say carbon has a smaller size than aluminum, or aluminum has larger size than carbon atom. So everything is going to confirm each other. How about the next one? Selenium and iodine. Selenium is here and iodine is there. I may ask you to pause the video and see your answer is going to be same like mine or not. So whenever we are going to reach iodine, we may go like this, from left to right and then down a group. First, based on the period movement, we say left to the right. Left to the right, size decreases. Size decreases. And how about if we have down a group? If we have down a group, we move from top to bottom, from top to bottom. So size increases. So as you see here, we have two opposite behavior, or we have two opposite result. So they are going to cancel each other, and we cannot tell which one is larger one. So if we have the same result, both increases or both decreases, we can compare our property. Otherwise, we cannot tell which one is going to be larger. So we are going to talk about this a bit later again. How about if we are going to talk about metallic characters or metallic properties? So metallic properties go back to losing electrons. If elements lose electrons easily, it means they are going to make cations. And we know that metals make cations. So we are going to know what elements or what type of elements can easily lose their electrons. If we are going to study that one, we say that larger size atoms, they lose electrons easily because there is minimum attraction between the nucleus and the valence shell electrons or valence electrons. So larger atom means we have highest or strongest metallic properties. So look at the periodic table. If you remember, largest atoms are placed here and the smallest atoms are placed here. For metallic properties, larger one, it means more metallic properties, and smallest atom, it means we have lowest metallic properties. So most metallic properties belongs to francium because it's the largest one. So francium is radioactive. Some textbook call that because francium is radioactive, we are going to pick cesium. But there is no change for our answers because we know that most metallic properties are placed in this area. And least metallic properties belongs to elements on the right side of the periodic table. If we are going to consider noble gases, we may pick helium. Otherwise, we may pick Fe as least metallic properties. Least metallic properties means most non-metallic properties, and we know that elements on the left side they are metals, elements on the right side they are non-metals. So metallic character decreases like size if we across a period, we move across a period, and if we have elements on the one group, metallic characters is going to increases like size. So size or metallic properties, both are same. If you have question regarding metallic characters or size, you should follow only one trend in the periodic table. So question says choose the more metallic element in each pair. Sn and Te. I'm gonna pick Sn here and Te here. They are placed in the one period, and we know that if we move from left to right, size decreases or metallic properties decreases. So it says which one it has more metallic properties. So we are going to pick Sn. How about Si and Sn? So let me erase that one and say Sn is here, Si is there, and we are going to move down a group. Down a group, size increases. It means metallic characteristics is increasing as well. So we move down a group, larger atom, so we are going to have more metallic properties for that. So Sn is that answer. How about if we have Br and Te? Br and Te, elements on two different groups or and period. So we are going to move to reach one of them. Br, I'm gonna move here and then catch and reach Te. So I'm gonna review that one. Down a group, size increases or metallic properties increases. Then right to the left. So if we have the period, right to the left, so size increases or metallic characteristics increases as well. So we are going to pick Te because we have the same behavior. Please understand, I reviewed size or you may review the metallic properties. Both are same because whenever we say more metallic, it means we are going to talk about larger atom because we know that what is the relationship between metallic properties, losing electrons, and size of atoms. How about the last example here? If we are going to study in this example, we are going to talk about Se and I. So Se and I, let me draw here and this one. So we need to move right and go down. And let's see how it works. If we have the period, move from left to right, size decreases or metallic properties decreases as well. How about down a group? Down a group, size increases. Look, down a group size increases. Or you may say metallic properties increases too. So opposite behavior, either size or metallic properties. So they cancel each out and we cannot tell which one it has more metallic properties. And finally, we are going to work on ionization energy. For ionization energy, I'm going to define ionization energy based on the terminology. We are going to make ions and we are going to make positive ion. To make positive ion, we need to remove electrons from atom. So if we use energy to remove one electron from atom, we call that ionization energy. First ionization energy. If we remove two electrons, we call that second ionization energy. So each element has number of ionization energy. It depends on the number of electrons. So for example, carbon atom, it has 6 electrons. So you are able to remove 6 electrons from this element. So we have 6 ionization energy. First one to remove the first electron, the second ionization energy to remove the second electron, and same like this one. So we are going to remove valence electrons. The electrons are placed on highest shell number or farther from the nucleus of atoms. What is the relationship between ionization energy and uh, size? So ionization energy increases from left to right and is going to decreases from top to bottom, top to down a periodic table, is opposite of the size. So if size increases, let me write it here. If size increases, ionization energy, let me abbreviate that by IE, decreases. So it does make sense because size increases, you don't need to use too much energy. Ionization energy decreases. If size decreases, you have very small atomic size, so you need to use too much energy to remove electrons to make ions. So for ionization energy, I'm going to write like this one. I'm going to write like this one. Ionization energy here, because we have a smallest atom, is in the highest form, and here we have largest atom. So ionization energy is lowest number. So you just need to remember the relationship between ionization energy and size whenever you are going to compare everything. So let me work on this example. Before working on this example, so as you see here, metals have lowest ionization energy and non-metals have highest ionization energy. So right now I'm gonna work on the examples. Which one has highest ionization energy in each pair? In each pair, magnesium and phosphorus. So please look, non-metal, metal. In general, metals have lower ionization energy than non-metals, but I'm gonna compare that one. I'm gonna say if we have elements in one period, size decreases. Size decreases means ionization energy opposite behavior. Ionization energy increases. Between magnesium and phosphorus, it has a smaller size and higher ionization energy. Non-metals. How about these two? Let me remove this and I say this one and this one. Elements in one group. One group. Down a group, size increases or ionization energy decreases. Ionization energy decreases. So this one is going to be higher, is going to have higher ionization energy. N and Si, let me delete here N and Si. N and Si. So we need to work on this. Two different groups, two different periods. Down a group to the right. So down a group, size increases or ionization energy decreases. How about from right to left? Period, right to left. size, if we are going to have like this, size increases. Let me write like this, size increases. And we say ionization energy decreases. So I intentionally compare with the size to make sure you just need to remember how to work with the size. So ionization energy decreases. This one has lower ionization energy than this, and we are going to pick nitrogen as an answer for this question. Oxygen and Cl, chlorine. So let me erase that one. Oxygen and chlorine. So this one and this one. So I'm gonna compare here. Period, right to left. So size decreases or ionization energy increases. And finally, if we have group, down a group, size increases and ionization energy decreases. So two opposite behavior. So we cannot tell anything about this. So as you see here, if we are going to study elements on two different groups and two different periods, if we have like this trend, we can predict. But if we have like this trend, we can't predict. So there are something you need to work on this to understand the trends in the periodic table. So hope these elements, these examples by comparing each trends help you to understand trends in the periodic table of elements. Thank you for watching this video.